to us.
So, Savannah, did you explain your answers to these questions?
Not really.
Neither did I.
So, welcome, ladies and gentlemen. We're taking a look at last night's homework, problem 14. We're talking about limits. And the trick we did for these, so this is the limit as n approaches infinity. And what I'm going to do is divide everything by n to the highest degree possible. I might even switch those two around. I kind of like standard form better, you know what I mean? So divide by n, and then it'd be plus 7 over n, all over 5n over n, right? And then if this simplifies, let's see, that's equal the limit as n approaches infinity. That would be negative 2 plus 7 over n all over 5, right? And now if I take it to the limit, the limit as n approaches infinity of negative 2 is negative 2. The limit as n approaches infinity of 7 over n. That's going to 0. Bless you, by the way. And the limit as n approaches infinity of 5 is 5. So this is just approaching negative 2 over 5, or negative 2/5. Or negative 0.4 if you're interested in that. You may recall our rational equations, graphing, asymptotes, blah, blah, blah. And anytime it was a tie between the leading coefficients, our horizontal asymptote was the ratio of their leading coefficients. So if the degree was the same for the leading terms, you just take the ratio of the leading coefficients. And that's kind of what happened here, too. But we're approaching it from just a purely limit side of things, not necessarily a graph side of things.
I hope you don't mind. I used a star in place of limit as n approaches infinity, so I wouldn't have to write it a bazillion times.
That wouldn't be tolerated at mathematical conferences, or on SAT, or anywhere. It is too bad there isn't like
but
a...
in homework, is it tolerated?
In your case, I might allow it. So let's see, limit as n approaches infinity of n cubed divided by n cubed minus 2 over n cubed all over n squared over n cubed. So this is the same as
n minus 0.
well, that would be 1, right? Wait a minute.
Yeah, 1.
Yeah. Minus 2 over n cubed all over
1 over n.
1 over n.
Which means that the top is being multiplied by n.
True. Yes. This is an interesting case. Now, if I tried to take the limit here, this would approach 1, this would approach 0, this would approach 0. And I'd get kind of a 1 over 0 situation, but I'm never actually dividing by 0. I'm dividing by something that's approaching 0. And if I divide by something that's getting smaller and smaller and smaller and smaller, correct. So this is approaching infinity. However, I see why your question was that earlier. That's what it is approaching, but since limit has to specifically equal a number, that's why the b does not exist. So, but I liked your consideration here a moment ago. You said that's the same as I could just multiply by the reciprocal of this denominator, right? And that might bring some further justification. And if I multiply this by the reciprocal of that, n over 1, right? And now take these limits. This is approaching 0, this is approaching 1, and this is approaching, that's just getting megundo large, right? That's what's happening there. So the actual answer is DNE, which is an appropriate abbreviation. Mathematicians would know what you're saying. Yeah, it just means does not exist. So the limit does not exist because it was approaching infinity. And limits also do not exist if from one side, if it was approaching like two different values, even though it was approaching them, depending on some sides. Like, yeah. So let's look at another one. Is there another regular one before I do something like 22? Kind of like 18. 19? 19. Yeah, 19 is at least a full mess of work on 19. It's a good one. 19 is like more purely what types of problems we did talk about yesterday. So let's see. So that is the limit as n approaches infinity of 8n squared over, and what am I dividing each of these by?
N squared.
Right. So all of my denominators are n squareds. N squared, n squared, n squared, n squared. And now I can simplify. So that's the limit as n approaches infinity of 8 plus 5 over n plus 2 over n squared all over 2 over n plus 3 over n squared. So, similar situation. So this is approaching 8, this is approaching 0, this is approaching 0, this is approaching 0, this is approaching 0. And this is going to be kind of a similar situation, isn't it? Yeah, 19 is the same, yeah. So yeah, so this is these numbers are getting smaller and smaller and smaller. They're never actually equal to 0, all right? Because 2 divided by a really big number still isn't 0. It's just getting closer to 0, right? Just like our example, you'd be getting closer to the door. You're never technically reaching the door. So this is a does not exist situation as well. Because this is actually heading off to positive infinity. All right, 8 divided by really small number is really big number. So it's kind of going to infinity.
Well, 8 plus really small number plus really small number.
Yeah. That's what we got. What about how about 21?
Hang on, I have
Question?
Yeah, I didn't get the answers to the even problem.
Oh, good point. I'll put those up there in a little bit. So 21. Now we've done exponential functions. Let's consider the graph of these two things. All right. So the graph of, if I had y equals n, let's say, that's a graph like that. That's a straight line, right? Or if I graph the function y equals 3 to the n, that would be small, and then it would and it would just get super steep because it's exponential. So in terms of comparing these things, yes, both numerator and denominator are approaching infinity, but 3 to the n is so ridiculously larger than n that it's almost negligible. It's kind of like, what's going on there? Actually, I wonder...
They both go on forever, but 3 to the n is several times faster.
Yeah, hugely faster. So if I'm dividing mondo big number divided by other big number, or actually, sorry, I'm dividing a big number divided by a mondo big number, this is going to be approaching 0 over time, is what's going on. So this one, the analysis is a result of comparing two things and their growth rates is kind of what I was doing. Let's see. Did the book say anything cool about that? Yeah. Did the book explain its reason? 21. No. I didn't know if it had any cool explanation. No, it's just 0. But we will talk about this sort of concept a little bit more in other sections, but I just wanted to justify it. So this is really like small number divided by, like, this is going to be so big compared to this small number. So fast, right? And yes, I agree n is going to infinity, but it's getting there a lot slower. It's like I don't know, if me and my grandma like had a race and we had unlimited time and energy and I was just like running and I'm just like moving along and my grandmother's just like with a walker and then like she's like, well, hey, let's just call it a tie because if we both have infinite time and energy, we're both going infinitely far. And I'd be like, wait, but I'm so far ahead of you. What are you talking about, Grandma? She's like, no, we're both going infinitely far. And I was like, come on. Like, and I'm just like, I'm just like so far away from her. You know, we're both going infinitely far.
You're just getting it's like a bike rider in the Flash racing to find the edge of the world so they can jump off of it.
Okay, maybe. Yes. But yeah, so the point is, like, comparatively, right, one is just growing so much faster. And then let's look at the last one, 22. Now, 22, I'm not going to do the whole thing out, but I'm going to explain what's going on here. Negative 2 to the n, well, 2 to the n is going off to infinity, all right? Actually, does this fail on several regards? It does. First of all, yeah, if this was positive 2 to the n,
That'd be different.
well, it would still be it does not exist.
But it would be less than it does not exist.
Right. It's like this one is just so far from being a success. It's failing in all cases, right?
Is the denominator 4 divided by n or 4
That's
plus
4 plus n, yeah. So 2 to the n is mondo huge, right? So this would be like dividing the mondo huge number, right, by a much smaller number that's also infinitely huge. But because it's so much bigger, the ratio of those comparisons is, you know, it's going to be approaching infinity. But the issue is for evens, even n, it's approaching positive infinity. And for odd ends, odds and ends, it's going to negative infinity. So this problem disagrees with itself, all right? Limits only exist if it's approaching the same thing, all right? So that doesn't quite work out. Later on with limits, we'll talk about continuity at a particular point. So like, for instance, so I guess as just like a little extension of this concept. So suppose I had this piecewise function. So here, well, I guess I might as well make it at 0, right? So that way it makes sense. So let's say as I approach 0 from the left, it's approaching this value 1. But then down here, as I approach 0 from the right, it's approaching negative 1. So if I ask for this graph, what is the limit as n approaches 0? Because there's disagreement depending on what side I'm approaching it from, the limit would not exist. All right? So if this is f of x, I would say dne. For that similar sort of situation, because it's not approaching the same number. It has to agree from both sides. All right? And that's kind of what's going on with 22. Sometimes it's approaching positive infinity, sometimes it's approaching negative infinity. Can't make up its mind. Right? It's like just particles that are exploding far away from themselves, right, in those two directions.
So the answer is 0. Is that does not exist? No. 0 is
right. Oh yeah. So this does not exist up here too. Yeah, 0 is okay. It can't approach 0. Actually, I was just thinking of, you know, an easy misinterpretation of infinity. If I'm thinking about the number line, and I was like, all right, how many numbers are there on the positive half? You'd say infinitely many. And then how many numbers are on the negative half? And we'd say like infinitely many. So the length of the number line is 2 infinities.
No, it's just infinity.
Yeah, it's just
That's
infinity.
a paradox.
infinity is
Even infinity squared is the same.
Right. Although infinity to the n, right, or a number raised to the nth power, right? In this case, interesting situations can occur.
infinity to the infinity.
So that was last night's homework.